Warm up for lesson 6-4. Pause. And here's the answer. Pause. And here's the answer. Pause. And here's the answer. I found the point HK, and then I realized that there was a reflection. So that point is actually going to be a maximum, not a minimum, because of the reflection. Lesson 6-4, nth roots. Objectives, simplify radicals. Let's take a look at our old friends squares and square roots. Now you can see that the square root of 2 squared, which is another way to say 4, is going to be 2. So look at all of these, because this is what we are going to be thinking of this as. This is really a composite function. It's really f of g of x. And the function inside is a squaring function, and the function outside is a square root function. They are inverse functions. That's why we get the number 2. That's why we get the number 3, 4, and 5. Let's take a look at nth root functions other than squares. So x to the third power is 64. And if I take the cube root of 4 to the third power, these are going to be inverses. They undo each other, and therefore the answer is 4. And that's what we're getting here. And we're going to do the 5 is the fourth root of 625, 2 is the fifth root of 32, and a is the nth root of b. Let's go to our calculator and see what our calculator says about the third root of 64. So the way you access a root is you go to math, and then you pick this root, number 5. Now I'm picking the third root, so I'm going to put a 3 there, and then I'm going to put the 64 like I originally had. And when you enter, you get a 4. I'm going to do it again. Again, 5, third root, but this time I'm going to put 4 times 4 times 4, and I get the answer 4 again. I'm going to do it one more time with taking the third root, but this time I'm going to write, instead of 64 and instead of 4 times 4 times 4, I'm going to write 4 to the third power. This is what I wanted to introduce. I wanted to show you that these two are inverse functions, and just as we predicted, they will undo each other and you will get the answer 4. And you can do this for all the others to assure yourself that these processes are inverse. All right, let's take a look at the nth root, because we can do third root, fourth root, fifth root, we can go up. So let's look at some definitions. This is the nth root symbol. This is called the index, what root you want. That is called the radical sign, and inside is called the radicand. When we take a look at a square root of 25, the answer is 5, and we call that the principal square root. That positive part, the non-negative root, is called the principal root. If we take negative square root of 25, that answer will be negative 5, and we call it the opposite of the principal square root. Now when you put both symbols, of course you're going to get both answers, and you get both square roots answered, the principal and the opposite of the principal. All right, let's take a look at some things that we need to understand about nth roots, especially evens and odds. Now, if you have x squared equals to 9, you know that when we take the square root, I've always told you that you're going to have 2 roots, and that's what this is saying. When you have an even number and the number you're taking the square root of is positive, then you're going to have 2 roots, the negative real root and the positive root as the principal root. If a ends up being less than 0, so if this number here were negative 1, you're not going to have any real roots. And if it's equal to 0, of course you're going to have 0. Now let's talk about odd roots. So x to the third power equals 8. I'm going to take the third root on both sides, and you can see I'm going to get the number 2. So when A is positive, you're going to get one answer, one unique positive for an odd power. Now, let's take a look at when you have a negative 8. So x to the third power is equal to negative 8. If you take the cube root of both sides, you're going to get the answer negative 2. So this says when the number that you're taking a root to is negative, you're only going to get one negative real root. Now when it is 0, then you're just going to get the answer 0. Let's take a look at some examples. Now you can see right here, I'm already seeing that I'm going to have 2 answers. What I want to do is take my Radican and rewrite it and look at how I'm using the powers. 4 to the second power is 16. Y to the second is y to the fourth. So I know that this represents this. Now the square root, this square root and the square are going to undo each other, and so you're just going to be left with this right here, and don't forget the plus or minus. Let's take a look at this. Now we can see our answer is going to have a negative symbol in front of it. I'm going to rewrite this as x squared minus 6 to the fourth power to the second. I know 4 times 2 is going to make 8. Now why did I want this square? Because the square root and the power to the second power will undo each other, and you're going to be left with what's inside the brackets. And this answer will be the opposite of the principal square root. Let's take a look at another example. This is an odd root, and what we're going to do is we're going to rewrite 243 as 3 to the fifth power. We can write a to the 20 as a to the fourth to the fifth, and b to the fifth to the fifth. So if I were to take every one of these, I would get back to here. Now why did I pick to the fifth power? Well, because my root is the fifth, my power is 5, those undo each other, and I'm just left what was inside the parentheses. Okay, let's do one by scratch. Okay, this is a square root, so I know I'm going to have plus or minus, and then I am going to write this to the second power. Now that means that 36 will be 6. 6 to the second power is 36. And then I want this to be x to the fifth, because x to the fifth to the second will be 10. This is a square root. This is a power. They undo each other. I need to still have the plus or minus. And then I'm just going to write what is inside the parentheses. There we go. Okay, so this answer is negative. So I know I'm going to have a negative in front of it. I have this square root, and I am going to somehow write this expression to the second power, because this is a square root and this is a second. I want them to undo each other. So this will be y plus 7 to the 8th power. 8th power to the second power will make 16, and that's what's going inside the parentheses. So I'll have a minus, the square root and the power are going to undo each other, and I'm left with what's inside, which is y plus 7 to the 8th power. Your turn. Pause, and here are the answers. Let's talk about higher powers and the need to use an absolute value. Okay, over here we know that this is an even power, and it's implied that this is a positive answer. So we must make sure that we get a positive answer. So when we rewrite it, this is going to be y to the fourth power. Now a fourth power and a fourth root and a fourth power are going to undo each other. And some students would like to just write the answer y. Unfortunately, we have to guarantee we're going to get a positive answer. And y may have been negative when we first put it in. So we must provide the absolute value sign to ensure that what we wanted in the beginning, a positive number, is what we're going to get here. Okay, over here in this one, we're going to do much the same thing. This is a even power. They're and the number or the sign that's in front of it is assumed to be positive. So when we get the answer, we must be able to assure ourselves that we're going to get a positive number. All right, so this is going to be to the sixth power, and I'm going to write something to the sixth power here, which means I'm going to inside have a 2, and I'm going to have x squared minus 3 to the, I want third power, because I want 3 to the sixth power, 3 to the sixth power to make 18, and I know 2 to the sixth power right here, 2 to the sixth power will be the 64. Now, if you're not being careful, you would think the answer is 2x squared minus 3 to the third power. Unfortunately, something to the third power could still be a negative number, and we have to assure ourselves we're going to get a positive number. So you must make it positive. Now, you don't have to have the 2 inside. If you have it inside, that's fine. If you want to move the 2 outside, it's okay too. All right, let's go ahead and do some problems from scratch. I have to make sure my answer is positive. So I'm going to write this something to the second power, and I'm going to have a 6 and a y to the third, because y to the third to the second makes 6. So my answer is going to be 6y to the third. Unfortunately, this could be a negative number because something to a non-power, but I was told at the beginning I should have a positive answer. So you must provide the absolute value sign. Let's go ahead and do this one. I want to somehow make it to the fourth power, and so that's going to require that I write a 2, and then I write x minus 3, and I want it to the third power because the third to the fourth makes a 12. All right, they undo each other, and I'm going to have this. But a third power could be a negative number, and I was told here I must have a positive answer. And so you must provide that. Your turn. And this is the answer. Your turn. And this is an answer. This is an odd root, no need for absolute value sign because the answer could be positive or negative.